Greetings, geometry students. Today we're going to be taking one of our first looks into what will be several examinations into different types of angles. Today we are going to begin with the basics. Please copy down the title, types of angles, as well as your objective and your essential question. Our objective for the day is we're going to remaster the different types of angles and discover various types of paired angles. Some of these terms you will be familiar with, some of them you will not. Some of them we're going to have to pay some special attention to. There are some terms in this lesson that do tend to cause students trouble throughout the entire year, and I will stress those to you when we get to those. The language objective for the day is I'm going to demonstrate basic mastery of types of angles and develop an understanding of the angle relationships by responding to questions from provided diagrams. At the conclusion of the lesson and your studying, you should be able to answer for yourself. Can I categorize angles by their measurement, and can I identify the new angle types we discussed today? As always, press pause anytime you need more time to copy something down, and then press play when you're ready to move on. So let's begin. Okay, now types of angles. All angles, singular angles that is, can be categorized into one of four basic categories based upon their angle measurements. Three of these you are probably familiar with. One of them maybe not so much. The first one we're going to look at is the acute angle. Now you probably know that an acute angle is an angle that measures from 0 to 90 degrees. Okay. Now a typical acute angle would look something like this. I know you know what an acute angle looks like, but I'm always going to give you a basic diagram anytime we come up with a new term and a new definition. Okay. Now obviously there's a lot of different angles that could have been drawn right there. Point being, we are looking at an angle that it does not reach 90 degrees. Of course, when an angle does reach 90 degrees, we have a new category for it, and those categories are right angles. Okay. So by definition, a right angle is an angle that measures exactly 90 degrees. Now, when we say it measures exactly 90 degrees, this is not an instance of close is close enough. It has to be actually 90 degrees. 89.9 is too small. 90.1 is too big. It's got to be exactly 90 degrees. Now, right angles can actually take a couple of different appearances when they show up for us. This is one possibility that we may see with right angles, and I picked on this one to show you the little box that is down inside the angle near the vertex of the angle, and that is a little symbol, a communication to us that a right angle or an angle is exactly 90 degrees, that it is a right angle. So as I say there, a small box might appear near the vertex of the angle. Now it does not mean if they do not show that box that an angle is not a right angle. It's just one of the forms of communication that we might see in geometry. After we climb up and go higher than 90 degrees, we have yet another category, and that category would be obtuse. Okay, probably another category that you're already familiar with. And an obtuse angle is an angle that measures between 90 and 180 degrees. A basic picture that might go along with that could look like this. And of course, again, there's a lot of different possibilities could have been drawn to demonstrate an obtuse angle, but what we're looking at is an angle that is larger than 90 degrees. Now there's a fourth and final category that you may or may not already be familiar with, and that deals with what happens when an angle actually reaches 180 degrees. And that type of an angle is referred to as a straight angle. As I already alluded to, straight angle means it measures exactly 180 degrees. And the diagram should look familiar. We have already seen two different instances of diagrams that look like this. This looks identical to a line and also opposite rays. Okay, so several different structures in geometry can actually create this diagram, and one of those is the straight angle. Okay, let's move on. Now, looking at different types of pairs of angles, here's one that causes us problems throughout the year, and it has to do with, I think, the fact that we don't learn what the word adjacent actually means. Now, this is one of the first instances that we're going to see in geometry where we have a word in the English language, adjacent, and now we have this word in the geometric language, which is also adjacent. However, the definitions in the English language and the geometric language are not the same definitions, and this causes us problems because we don't bother to learn both definitions depending on which language we are speaking. Okay? In the geometric language, adjacent means angles that share a leg. In the English language, adjacent would be something next to something else. Well, these are actually appearing to be next to each other, but simply saying they're beside each other doesn't really tell the entire story. They obviously, here, angle 1 and angle 2, they have a leg that is in common between them. They share it. Okay, so angle 1 and angle 2 are examples of adjacent angles. Unfortunately, we have no symbol or symbolic notation for adjacent angles, so when it comes time to answer a question about adjacent angles, you're going to have to actually write the words out. Okay, here's a term that we are probably already familiar with, and it is perpendicular. Lines that intersect to form a right angle are called perpendicular lines. Actually, we've already seen an example of perpendicular lines, actually perpendicular rays, a moment ago when we looked at the right angle. We had two rays coming from a common endpoint, and they formed a right angle. Those rays were perpendicular. These structures that you are looking at now, they are perpendicular to each other. For example, we would say in this case, line BC is perpendicular to ray DA. Okay, now please notice there is a new symbol that is in that last little identifier down at the bottom, last statement, and it looks like an upside down capital T. And that upside down capital T is the symbol for is perpendicular to. Okay, so please make note of that. And let's move on. Okay. Now, another angle pair is called a linear pair. This one causes us problems throughout the entire year, and why it causes us problems I do not know. I warn geometry students every year that this is a definition that we're going to need to get memorized, and year after year we seem to continue to struggle with it. A linear pair is two adjacent angles that form a straight angle. Now, if you notice in that definition, we have three terms, actually, linear pair, adjacent angles, and straight angle. So you're kind of caught in a spot where you need to know a whole bunch of vocabulary, and you're going to see this in geometry quite a bit, where we define a word, and then that term becomes part of a definition for another term. Okay, so if you have even one term that you don't bother to learn somewhere along the way, it can absolutely continue to raise its head and cause you problems over and over again. Okay, so a linear pair is two adjacent angles that form a straight angle. So here is a possible example for you. These two angles, angle 1 and angle 2, they share a leg, the one that's kind of moving up and to the right, and then the other legs of the two angles, when you look at them, they form a straight angle or a line. Okay, that is the definition of a linear pair. So we would be able to say angle 1 and angle 2 are a linear pair. Now again, there's no particular abbreviation or accepted symbol for linear pair, so when it comes time, you're going to have to write that one out. Here's another one that causes us problems, and again, this is an issue with conflict between the geometric language and the English language, and this term is vertical angles. Now, typically when we think of the word vertical in the English language, people think, oh, vertical means up and down, so that means vertical angles must be up and down from each other, and that is not really true at all in a geometric diagram. Vertical angles are angles that are across from each other wherever lines and rays and line segments intersect. Okay, so a potential example might look like this. We have a line segment and a line that are running across each other, and as you can see at the intersection there are 4 angles that are formed. Now, true enough, angle 1 and angle 4 are vertical angles. Okay, but they are not vertical angles because they are oriented vertically from each other. Okay, vertical angles simply means they are across from each other at an intersection, and that's true. They are across from each other at that intersection. However, that is not the only pair of vertical angles that is at that intersection. There's one more pair that is also across from each other, and that would be angle 2 and angle 3. Those are also vertical angles, even though in the English language we would say that they are horizontal from each other. Okay, just another one of those situations. The word vertical does not mean the same thing in English as it does in geometry, so you're going to have to learn a new definition for an old word. There's a rule that comes along with vertical angles, and the rule is that vertical angles are always going to be congruent to each other. In those pairs, they're going to be congruent. Now, hopefully you remember that the word congruent means equal measurement. Okay, so in this diagram, we've got angle 1 and angle 4 are going to be the same measurement, and angle 2 and angle 3 are going to be the same measurement. That's just how it works. Okay, here's a couple of terms you might be familiar with. Okay, complementary is one of them. Complementary angles are angles that sum to 90 degrees. Now, hopefully we remember from back in the day, the word sum means the result of an addition problem. So we have 2 angles that are going to add together, and the result of that is going to be a total of 90 degrees. Now, there's a lot of different ways that complementary angles might show themselves. They could be adjacent, like we saw a few moments ago. They could be 2 different pieces of a right angle, or they could be 2 entirely separate angles like what we are looking at right here. It does not matter how they are presented in a diagram. The only thing that matters is the fact that they do sum to 90 degrees. So since we have 2 angles here, angle ABC and angle DEF, remember that when you are naming angles, you must list the vertex in the second position. That's the B and the E in these cases. And we would say that these are complements of each other because they do sum to 90 degrees. Okay, and then we have supplementary angles to go along with that. And if you knew what complementary was, you probably knew what supplementary was as well. Supplementary angles are angles that sum or add up to 180 degrees. And once again, these can show up in a lot of different ways. Perhaps they show up as part of a linear pair. Perhaps they show up as part of a demonstration of opposite rays. A lot of different ways they could show up. Maybe they're completely separate like you're looking at right now. Doesn't matter how they show up. The property that these are obeying is that they do sum to 180 degrees. So in this case, angle RST and angle XYZ are supplements of each other. Now, if you've heard of these terms before but always kind of had a little bit of an issue of trying to remember which one is which, complementary is 90 degrees, supplementary is 180 degrees. I will give you this one cutesy little thing I kind of tell people year after year. If you think about the terms complementary and supplementary, think about them alphabetically. Which one would come first in the alphabet? Well, obviously, complementary would come first. C comes before S. Okay, so complementary comes first in the alphabet. Now look at the angle measurements. Okay, if you were starting to count upwards from 1 degree, which angle would you run into first, the 90-degree angle or the 180-degree angle? Well, counting upwards, obviously you would run into 90 before you run into 180. Okay, so if you kind of think about that, it has that in common. C comes before S in the alphabet. 90 comes before 180 when you're counting. So the complementary and the 90 go together, the supplementary and the 180 go together. Maybe that'll help you keep them straight. Okay, I want you to go ahead and copy down this diagram as well as the different topical examples that are on the screen now. Okay, so we have basically kind of an open-ended or question at the top. Are there any blank in the diagram? And then there's a lot of different types of angles to fill in the blank from there. Okay, so we're going to copy down this diagram, and I want you to copy down the categories. And for your summary this time, instead of necessarily writing down the summary, I want you to answer these questions, and we will assemble all of the answers when we get to class. Okay, so find all the examples of acute angles that you can find, all the angles are examples of obtuse angles, all the examples of right angles, and so on. And then we will kind of compile all the information in class. I appreciate you finding time to get your notes taken care of. Have a good night.